recording. Okay, so welcome back yet again for CSE 101. This is November 19th, and so we're going to finish up our discussion on repetition on loops. I got a few more slides I want to go over with that, just some final points to make about that. And then we are wanting to go ahead and get into methods today, because methods are another very important thing that we get to use here in programming. So, sorry, one thing I'm thinking about is, so you guys, I guess for the next few weeks, you're going to all have to be inside during our class, I guess, or many of you, maybe not all of you, but many of you will have to be inside. So I guess you'll be stuck with me during our class time and just excited about class ending, so that it'll be about the time that you'll be able to go outside of your homes and get to do things, right? So I guess we just do what we have to do to make it through these strange, confusing times. All right, let me go ahead and share the slides here so that you guys can see what we're got going on. All right, so we're gonna, like I said, we're gonna finish up our discussion on repetition. One thing that I do want to go ahead and remember to start off with today is a quote of the day. So Scott Adams, if you don't know who that is, he's the author of a comic strip called Dilbert that is about engineering. He worked as an engineer for many years, but his comic strip became so popular that he was able to do that instead. But a couple of quotes from him. So normal people believe that if it isn't broken, don't fix it, just let it go. Engineers believe it isn't broke, it doesn't have enough features yet. Meaning that we just like to keep gold plating our things and adding more and doing new fun things that aren't necessarily what always were asked for initially, but we think it can be better. That's one of the hallmarks of being an engineer. We always think about how things can be better. One other quote by him that I liked was, engineers like to solve problems. Remember, we do not do questions and answers as engineers. We do problems and solutions. Remember, the difference, one of the big differences is a question has a single bright answer. A problem has many correct solutions. Okay, some better than others, but many possible correct solutions. We talked about this last week, so hopefully you remember my example of how to, just something simple, how to print the word hello to the screen, and that there were 3 different solutions I showed, and those aren't the only ones. There are many others as well. Okay, so it looks like the power just went out at my home, which means the internet is out here. So I'm not sure. Let me do this. We will put this meeting on pause. I'll go ahead and end this meeting. If the internet comes back within the next, when the internet comes back, we'll restart this meeting. Okay. I don't know if what's been recorded so far will get saved or not. So I'll be sure to check that out whenever the internet comes back. Okay. Hopefully you guys can hear what I'm saying. I had to call from my phone. I don't know if my phone has enough internet service data on it to be able to do a hotspot or not. So yeah, so I'm sorry about this. So we'll see if we can get this going, if this can get back running again within the next few minutes or so. All right. Thanks, guys. Sorry. Okay, let's see. Still recording. Okay, so it says it's still recording. All right, let's see if this works. So I've started the meeting up again. So the power's still out here, but what I'm doing is I'm setting up, I went ahead and turned my phone into a hotspot. So we'll see how well that works, if that lasts, how much data that ends up taking. I'll take a look at that at the first break here. And so let's just go ahead and get underway. Assuming you all can hear me, can anyone please just make a comment that says, yes, I can hear you, Hoja, so that I can know that. Okay, thank you, good. All right, so what we, quote of the day, just go ahead and take a look at that. have fun with that. But let's go ahead and move on into the next stuff here. All right, so loops we talked about where you basically keep doing something until a condition is false. You keep, as long as a condition is true, you do what's inside of the loop. And you keep doing that over and over again until the condition is false. So if we go back and look at some example, where was it? So like here, for example, while true, do something, would mean that basically this would be kind of like an infinite loop on its own, right? That this condition will never be false, right? So there should be, for those situations where we might end up in an infinite loop, that what we can do is we can have a way to break out of the loop or get out of the loop, all right? So this is how we can do this using the continue or break statement. Now with break, you remember break from when we talked about switch case statements, all right? Hopefully you remember switch case in our if our conditional stuff. All right, our if statements, so the switch case was a different way. Break got you out of that switch, right? In the same way, break will get you out of a loop you are inside of, that it will exit the loop and will go to the end of the loop and it's done. Okay. Continue goes back from wherever we are, goes back to the condition and checks it again without doing anything else for the remainder of that loop. So let's take a look at how this works in practice. Okay. So here we have this while loop. While number is less than 20, we start with 0, number is less than 20, we execute this. Number, add 1, sum, add whatever number is to sum. Right? So if we insert a little table here, do this pretty well, is, let's put this table here. Oh, it's not. I want to make more keys in there. Okay. Or what we can do is we can try kind of track the values of what sum and number are. Right? Okay. Okay. So sum starts out as 0, number starts out as 0. Okay. So we check, is this true? Yes. So add 1 to number, so number becomes 1. Okay. Add number to sum, so sum becomes 1 also, 1 plus 0 here. Is sum greater than 100? No. So we go back. Is number less than 20? Yes. So we add 1 to number. Okay. Now we add sum equals sum plus number. 1 plus 2 is 3. Okay. So then we check it again. Sum is not greater than 100. 3. Then 3 plus 3 is 6. And notice that this will only, the only time we get out of this loop, the only thing is going to be important is if sum is greater than 100 or number is less, or number is 20 or more, right? So that becomes 4, which means that becomes 10. That becomes 5, which means that becomes 15. Now it's growing, right? This becomes 6, which means that becomes 21. This becomes 7, which means that becomes 28. It's going to start growing really a lot here shortly. 9, 45, 10, 55, 11, 66, 12. What's 66 plus 12? 78. 13 plus 78 is 81. Let me move this up because it's going to move just off the edge there. 14.
So, I guess you are not recording the lecture.
Is it not recording?
Not recording.
Oh. Let's. See. Okay, it said that it was recording. Let me. It says, yeah, it says it is recording right now. I don't know. because it gives me on the drop down, it says it gives me the option to stop the recording. So it must think that it's. We'll find out here in a moment. I'll check it. Okay, let's finish this up real quick. So 14 plus 81 is 95. Okay, so we're getting close. So let's see. Is sum greater than or equal to 100? No. So we skip over this. We come back. Number is less than 20. So we add 1 to number. We add number plus sum, and we get 110. Now is where we hit this if statement, right? So if sum is greater than or equal to 100, we break. So that means we don't go back and check this again. We break out of the loop, and now we go and we say number is 15, and the sum is 110. Okay. Could we have just made this sum is greater than or equal to 100 as part of the while loop condition? Absolutely. In fact, I would say usually that would be a much better way to do it, because if you do it in this break, it's a little bit confusing. It can give us weird, like we don't know where it's supposed to, the natural loop ending. Controlling the loop through the condition up here is much better, is a much better way to control it. Okay. Let's see. I'll close that. Let's see what's going on. Oh, you're not seeing the slides. Oh, I'm so sorry. I see now what's going on. I had clicked on this on a different window. Okay. I'm so sorry, guys. I think you guys should see the slides now. Is that right? Are you seeing the slides now? Okay, thank you. I'm sorry, guys. So when you were asking about the recording, I think what you meant was you were concerned that the slides weren't being shown, I think is what you were saying, right? All right. Confusing morning, guys. This lockdowns and everything's just getting us all messed up, right? Okay. So if we go back and, okay, so here, this was the chart I was doing that. I was hoping you guys were going to see this while I was doing it, but sorry. So where we start out with sum and number as 0, and then as we go into the loop, we add 1 to number, then we add number plus the current value of sum to get the new value of sum, right? Then we go back and we do this over and over again until either number is 20 or greater, or if gets seen, if the sum is greater than or equal to 100. And it's kind of a race condition of which one's going to get there first, right? So in our situation here, number is less than 20. That is never false till we get to, that's never false as far as we've got. But this became true. Sum was greater than 100. So we execute this break and we get this line here. Now, if this instead, while number is less than, let's say instead of 20, if we had said 10, this would have been where we would have ended the loop. We would have ended back over here, okay? And actually, so number would have become 10, sum would have become 55, and then we would have exited the loop, okay? So that's how we can use a break statement. Again, I suggest strongly that you try to not use break statements to exit loops because it's a little bit more confusing for those of us reading your code. It's much better if we control the loop through the condition. But this is an option for if a weird situation, especially if an error type situation happens, that we can break out of a loop. Okay. Another that's similar is continue, but continue, instead of breaking out of the loop, continue just skips any remaining lines in the loop and goes back up here and does this. So if we kind of take this and we put it here, we look at what how this is going to work. Okay, so sum and number both start out as 0. Numbers less than 20, yes. So we add 1 to number. If number is equal to 10 or number is equal to 11, which it's not, then we add number plus equals sum, so 0 plus 1, is now 1. We go back, number is now 2, means 3. I guess I could have actually left. Let me copy these values into place. Reason why is because really this just kind of follows the same pattern until we get to now number is equal to 10. Okay. Now, if number equals 10 or number equals 11, we continue, which means we skip over this. So sum doesn't change. Sum stays 45. So then when number becomes 11, the same thing happens. We skip over it again. So now when number becomes 12, the sum is 12 plus 45, which is 57, right? So notice it's slightly different from here, the pattern we followed here versus the pattern that just followed here. Now number becomes 13, sum becomes 70, right? Okay, so if these two values are hit at some point, we continue, we skip over the other lines in the loop. Okay? And I won't play this out the rest of the way. You can run this code to see what it would look like. Okay, but these are two different things that we can use to control the loop that aren't the conditions. Again, you know, I suggest strongly that you try as hard as you can to control the loop through the condition in the loop condition, not through some internal mechanism. Okay. All right. So that concludes our lecture set on repetition. Let me get out of here. Like I said, I'm gonna go a little bit probably faster than I would have liked to, only because I'm not sure how much this internet thing is going to work out for me today. So we'll do our methods. Okay. So that, like I said, that finishes up repetition. That finishes up loops. Now we're going to talk a little bit about methods. Okay, we're going to introduce methods today. We'll finish up our discussion on methods next week. Okay. So let's say, like one of the things we talked about, we saw how to do this through a loop. If we wanted to find the sum of numbers from a starting number up to an upper number, all right? So if we wanted to add the numbers 1 to 10, if we wanted to add the numbers from 20 to 30, if we wanted to add the numbers from 35 to 45, right? We could write a loop to do that. We could write a pretty easy loop we could even write a single loop that would get, before we executed the loop, we got the information from the user where we said, okay, enter the starting number and save that in a variable using the next int method. We could give the second number, and then write the loop, right? But sometimes we don't want to, what if we needed to use that different stuff in multiple different places? So we don't want to have to write, you know, a loop for one set of values, then another loop for another set of values, then another loop for another set of values. What if what we would like to have is kind of this box? Okay, so I'm gonna put in some symbols here so you guys can see what I'm talking about. This box. Where's shapes? This one. I want shapes. All right. So we have, like here, this box, and we put into our box two values. One would be like a start value. So we put in a start value and an end value. And we get out of the box an output. Okay. And the output is what is the sum of numbers starting at start, ending at end. So if we put in 1 for start and 10 for end, we would get out the sum of numbers from 1 to 10. So 1 plus 2 plus 3 plus 4, all the way up to 10. If we put 20 as the start value and 30 as the end value, what's inside of here would calculate the numbers from 20 to 30, adding them up and giving us that output. Okay. That would be a much better way to do this, right? Where we could have this box, right? That we could say, put these two numbers in, get this one number out. right? That way we wouldn't have to have this loop that's a loop that's based on whatever the user entered. So if we see that this is kind of the same code multiple times, just slightly different, just a little bit different each time. Right? What we could do is we could say, let's have this. Let's have some a sum method that takes a starting value, takes an ending value, adds up the numbers from the start up to the end. Notice here, so sum plus equals I, whatever I is. I starts at the start value, ends at the end value, adds them all up together, and then returns that value. That's basically what happens here. So if we take our little box, I want to get the whole thing. We take this here, right? And actually should be all lowercase. Okay. So this would be the sum method. We put in a start value, we put in an end value, we get back the sum of all the numbers from start to end. Okay. That's how this can work. And then we can call that method from somewhere else. And when that method gets called, these lines get executed based on these values, and what gets returned gets replaced here. So whatever the sum of numbers from 1 to 10, what is that? That's n squared. Is that 55? I think it's 55. What we can, yeah, it's 55. So what would happen is the value 55, when it gets returned from here, it would be like it replaced it here. And what would happen is this would print out sum from 1 to 10 is 55, would get replaced here. Okay, and when the code executes, it does that automatically. You know, it's not that we don't have to type in 55 here; it gets automatically put into there. Okay, look. How do we define these methods? Now, for this class, 102, we'll talk a little bit more about why some of this stuff is the way it is. But for now, you just have to know public, static, return value, method name, and any parameters. Okay. The way that we define it will be public, static, and then some other information. Okay. So just get into the habit of typing public, static. Okay. And then inside of this, inside of the curly braces, will be the code that is what's inside of that method. Okay. So if we see this max method, what it name implies is it wants to take whatever the maximum of two numbers is and return it. Okay. So here we declare a variable called result. If num1 is greater than num2, these are the two values that we've passed. If num1 is greater than num2, we say result equals num1. Otherwise, result equals num2. Because if it's not greater, then it's either less than or equal, right? And then we just return whatever the result is. So if num1 is greater, we return whatever num1 was. If num1 is not greater than num2, we return whatever num2 is. All right? And then we can pass variables, x and y. We could also pass, as we saw back here, actual values. Either way, we can do that with this. So we could pass max 1, 2, right? And it will return the value 2, and 2 will be assigned to z or z. So this is how we define the method over here. This is how we invoke or call. Actually, I want you to use the term call a method. Okay? This is how we define a method. This is how we call a method. Right. So some pieces of this. Again, this whole line here, we call this the method header. It tells us a lot of information about the method, about what's going to happen. For those of you who have any previous programming experience, you might have called these functions in object-oriented programming, and in Java specifically, we refer to them as methods. Okay, So again, public static, just get into the habit. We'll explain more in 102 about why these are what they are. So then a return type needs to be given. It needs to either be either a return type that we anticipate that we will be giving back from this method, or void. So you guys have been writing the main method here in your previous labs and your assignments and stuff. That has been a void method. Void is a special return type that means don't return a value. Notice that your main method doesn't return anything, all right? So it's just been void. It means it doesn't return anything. Okay, that is an option. But if you want your method to give you a value back, you need to tell it what type of value it's going to return. Okay. Then the method gets a name, much like a variable name. It needs to be descriptive, but the compiler doesn't care. It's the same rules as variable names. What can be the identifiers? Okay. Then you have parameters that you are going to be sending, right? So when we call this method, we need to give it the same number of parameters. We might call this parameters, we might call them arguments, past values. There's some ways that we might refer to this, okay? But parameters and arguments, you'll hear me say that a lot. So this is the method signature. So what this is telling us is when we call this method, we need to call it with this name and these number and types of parameters. So when we call this max, x and y have to both be integers. Okay. This is the method body. This is basically the code that will execute when this method is called, and then a return value. Every method that has a return type that's not void must have a return statement that returns a value. Okay, you'll get a compiler error if you don't have one. There are situations where you can have return statements that are inside of if statements, but if you don't make sure that a value will be returned, you could get a compiler warning. It won't be an error, but it will be a warning that you may not be returning in all situations. Okay. All right. So method signature, we talked about that. It's the name and the parameters. Okay. We would call these the formal parameters. They're the ones that will be used inside of the method. The actual parameters, on the other hand, are the values that we are passing. So up to this point, see, num1 and num2 could contain anything, right? But whatever is in x and y is going to be sent to, the value is going to be sent to num1 and num2. Okay. So we'll get into that a little bit more in a little bit. All right. One more thing about some of the pieces of a method return type. Now, these must match. If we return a type that is not the same as the type that's been declared, we will get a compiler error. Okay. So if we say that we're returning an int, we must return something that is an int. If we say we're returning a string, we must return a string. If we say we're returning nothing, if we say void, then we cannot return a value. If we do any of those, we will get a compiler error. Okay. We will look at an example, assuming that I can do that, on today's rather strange circumstances. Okay, so we'll go ahead and look at an example when we get to that time in the second hour. All right. So when we call a method, so let's say here we put a value into I, put a value into j, then we call this max method with I and j. The value that's in I, so 5, gets passed to being stored in num1. The value that's in j, 2, gets stored into num2. Okay. Then this is executed. The result is returned. So when this gets executed, we know 5 and 2. 5 will be stored in result. Result, that value will be returned. So 5 will be returned and put here. So then this will be basically the same as if we had typed int k equals 5. That's the way the program, when executing, will see it. So then 5 will be stored in k, and then we'll get this nice fun message that says the maximum between 5 and 2 is 5. Okay. Look at how the method is traced. Again, we go 5, j is 2, we invoke this. So pass the value of I to num1, the value of j to num2. Okay. Result has no value initially. Okay. Say num1 is 5, num2 is 2, so 5 is greater than 2. So we go inside of this if statement. Result gets that value. We return result, which is 5. Right, so 5 gets assigned to k, and then we execute the print statement. Okay. We'll look at one more kind of stack stuff in just a minute. This was an example of where a compiler warning could happen. Is in this example, let's say that we wanted to give a value based on whether the value passed. We want to say 1 for positive, 0 for equal, 0 for 0, and -1 if n is a negative number. Okay, this is pretty common for comparing purposes and stuff like that for doing things in when you compare two numbers and stuff like that. And we'll talk about that again in 102. So here's the problem. We can look at this as human beings and we can say, well, if n is greater than 0, it's positive, good. Otherwise, if n is equal to 0, return 0, it's not positive, it's not negative, it's 0. Okay. Otherwise, if n is less than 0, return -1. Now, we as human beings can look at this and say, well, all possibilities are covered, right? It's either positive, 0, or negative. There's no other options. There's no other possibilities. Right? The problem is that the compiler isn't smart enough to do that. Okay? The compiler is not smart enough to know that all possible options are covered. So what's going to happen is it's going to say, you can't do this. You cannot do this because I don't know if this method is definitely going to return a value. Again, you and I, human beings, we can look at this and say, well, no, it's definitely going to return a value. There's no other options, right? But the compiler isn't smart enough to know that. So this is why, again, we strongly encourage you to always have a final else in these if statements, if there needs to be one. There's some final else, right, that represents other conditions. So if n is greater than 0, 1, else if n is equal to 0, 0. Other possibilities. What's the only other possibility? This one, right? Return -1. Okay. It's good programming to do it this way. This just requires extra typing that's not necessary. But more than anything, in this situation, it can avoid you some compiler errors or compiler warnings. I think depending on your version of Java, some versions of Java would treat this as a compiler warning, where it would let you compile it, but it would give you a warning that there's a problem. Some versions of Java will treat this as a compiler error and will not let you run it. Okay, so like you're saying, you want to return from this DJ, you want to return an integer and a string, like you want to give it a value and a message as well. Is that what I'm understanding? Right. Okay. So methods will not allow you to do that. You can only return a single value. Now, what you can do is in the main method call, like where you're calling the method based on the value that gets returned, you can do something with that. Unfortunately, we can't return multiple types values. Now, what you can do, and this is a little bit, I would say this is probably more something I would discuss with you guys either in the next semester or even into the next year, would be the idea that what you could do is return some type of string that has within it some like comma delimited values or something, where you have a message, comma, a value, comma, something like that, and then parse that out. But that's something much more advanced than this class. For now, methods can only return one type. Like you can only return one value. Okay. Okay. Yeah. What you're saying, Muhammad Fatih, you can have a return after the else if. So if, like after this else if you had to return something else, yeah, that's outside of the if statement completely. You could do that, but in this particular example, that would just be extra, it'd be nonsense. There's no reason to do it that way. Usually we reserve something like what you're talking about. Yeah, usually what you're talking about having an extra return after the else if, that would be for an unexpected situation. So we would only use that for a, okay, we hit some condition that was never seen and we didn't expect that to happen. So you really only do that in a situation that where a strange abnormal situation to account for those. Okay. Let's see. Let's finish up this and then we'll take a break and I'll check to see what's my situation on internet. Okay. So the way that we can call methods from other classes, this whole static method. So like you've seen this before with the math.random or math.absolute value method, right? You've seen that before where we can do that with our own defined methods, where in another class, we can call class name. So like in this case, test max dot max. Right, so we call it class name dot method name, and we can call a method in another class. You've been doing that with the math methods. You've been doing that with string methods so far, right? So you guys have already been doing that, but you can do with classes that are predefined in Java. Now you're learning that you can do that with methods that you defined with inside of classes that you created. Okay. All right, so I did say let's go ahead and do this call stacks and see how the whole stacks, how the whole memory stuff works. All right, so we are calling the main method. So the main method, we set I, we set j to be what their values are. We call the max method. J and I get copied into num2 and num1 respectively. So I gets copied into num1. J gets copied into num2. The max method is executed, which results in result getting a value of 5. Then the method returns. So it returns back to the main method, replacing where that call was done. The max method finishes and the return value is set to k, and then we're done. We display our message based on that, and we're all done. Okay, so if we want to see it kind of in an animation format, I is set, j is set, k is declared, but no values given. We call max method, we go inside of it, the copying happens, I gets copied to num1, j gets copied to num2. Result gets declared, again, no values given yet. We check our condition. Result gets our value. We return that back to here. Replacing this with 5 means that k gets the value of 5. We display and we're done. Okay, so we're a little bit right at about halfway through the set of slides now, and it is time for our first break of the day. So what I'm going to do is I will wait until after this to do the avoid example. The void method, again, is when it does not return a type. It does not return int, it does not return double, it doesn't return string, it doesn't return anything. It just does some stuff. Okay. I'm confused about the question. Let's take our break. Like I said, I'll be available here during the break to answer some of these questions if you have some. I'm confused about more than one value in the main method. The main method doesn't return a value. It's a void method, so it doesn't return a value. So I'm confused about what you're saying there, Ozan. So if you can explain that a little bit better, what you're saying, how you use more than one value. If what you mean is we're declaring multiple local variables, that's fine. We can declare a million variables if we want to. We can declare as many variables as we want inside of a main method. Right. We can use strings, ints, all these different types because we're declaring them local to the main method, right? But we're not returning that value. The difference is in in the max method, for example, it returns a value from the method back up to the place that called it. Okay, so it's the difference between it's communication between methods, right? So I'll come up with an example. I'll try to come up with an example if that's still not clear during the break, because I have an example in my head involving homes and going outside, but I'm trying to think it through. Anyway, all right, so let's take our break. Let's do 10:30, let's do a little bit longer. Let's do 10:35, and then we will come back then. Okay? All right. See you in a minute. 10 minutes.